This video is about optimizing test coverage. What is test coverage? Well, you can look at it different ways, but one way of measuring it is code coverage, and another one is requirements coverage. Let's look at the first. Here I see a lot of red, but that's because I'm only testing here the user interface components. So the services and the repositories are not tested. So that explains why these are all red. What we are interested in is these three, and the code coverage is pretty good in the 90s. What is missing? Let's look at it. So here I see that, for instance, I have not any test for that, and I also don't have test for here, demo form, this here, handle exception. So there's still improvement possible, but I claim this is already pretty good. What test are we actually talking about? I have 142 tests, all generated by AI. The only one that is missing here is a pen testing test, and it started that, and then it decided to skip it because it concluded in the framework that I use, Blazor Server, with Entity Framework, SQL injection, and cross-site scripting are not an issue, so I don't need to look at it. Good. This is the application that I have. So um, this is the way I like to have my grids. You can select which columns you want. For instance, if I don't want that ID, I can, as a user, decide not to have that. And if I want to filter, I can just uh, get fewer records. And this view that I chose here is also preserved. So if I refresh the page to come back tomorrow, it's still there. Why do I mention that? Well, um, the second way to measure coverage is requirements coverage. And um, that is actually pretty good. It's 100% by default. Why is that? Well, if I look here, you can see that I instructed the bot, Claude, to generate a table from all the uh, acceptance criteria that it found in all the user stories. And then it generated this table, and you can see that all of these acceptance criteria are implemented. And that's because I asked it to do so. Then in addition, I asked it, so you would say 100% requirements coverage. In addition, I asked it, well, what acceptance criteria can you find that I missed? And there were quite a few, as you can see here. And here, for instance, this filter persistence, that view that I just showed that you can persist between sessions, there are no tests for it because I forgot to put acceptance criteria for that in there. And the same is true for sort persistence. So some of these are really valuable, others are not. But here it says you might want to support different viewport sizes, but it also says that may be out of scope, and it is for me because my applications always run on a desktop. But still, if you look at this, it found quite a few recommendations for additional acceptance criteria. This is wonderful because in the field, in practice, not all acceptance criteria make it into the list.
If you got this far, you may be interested in how I accomplished this test coverage. So let's look at how to achieve alignment. There are several ways. The first one is setting direction and verifying understanding. So I want to take a step back and look at how parents align with children. If a parent tells a child to do a certain thing, then what I typically do is ask the child to say in their own words what the instructions were. And that has several advantages because the child then needs to make the instructions their own and can then be guided by them. But also, you can then check that these instructions are actually properly understood by the child. So before the child performs the requested action, we ask it to say what it heard, and we listen carefully whether they got it. And the equivalent for that in um, working with bots is that we review what they understood or seem to understand, and then maybe make corrections. So we don't wait till all the tests are written and then go through the end result. No, we ask the bot to first generate a table of all the things it's going to do to create these tests. And this abstraction of the test we review. Another important thing is giving examples or leading by example. Here too, we can look at our world and say, well, what happens if we get a new engineer on our team? We don't show them an empty desk with an empty screen and say, good luck. No, we first tell them about the company, what the company does, where it gets its money from, what the role of the application is in that. And then we dive deeper and deeper, and we show code and zoom into the code that the person is actually going to work on. And we show examples of what they have to produce. And by setting those patterns, we make sure that, or make it more likely that we get a successful result. And chatbots are even better than humans in following a pattern, so here it's even more important to do this. What I use is I use a template and I include example pages. In the beginning, I saw it, the bot create white text on white background. So um, the way to concisely tell it not to do that is to already include menus in a sample application or in a template to start with. Um, and then it will just follow that pattern. It's also not good to say things like using an autocomplete field to select an employee because it's likely that it is going to create its own autocomplete component rather than taking one that you already prefer. So, example code. Here's some proof that it actually uh, follows those examples because here I have, it says, um, let me check if there are existing tests. And here it's let me check if the existing section test. So it's not only trained to look for patterns, it's also trained to tell us that it is trained so that because it knows we care. Okay. So being consistent is very important. I can go back to parents and children. Parents need to consistently set the example and not cause confusion. I cause confusion by very simple things, like I um, wanted it to use data test ID to identify elements on a page that were relevant in tests, and I didn't consistently use data test ID. That created confusion. Or even more benign, I had a test dash ID somewhere, and that caused the bot to stop and ask questions like, what do you mean? Is this something else? Should I know it? Is it the same? So be consistent. Establishing guardrails. Well, by now you know that the tests are the guardrails. Every time a test fails, it tells that something else is wrong. Well, that is if the test is correct. But if the test is about other user stories, then definitely the test is not to be changed. And the last way to ensure alignment is using source control. So if you see in a PR that the bot has changed existing tests, that's a red flag. That's almost certainly wrong, unless, of course, the story involves a change in requirements and therefore a change in acceptance criteria. But if there is no such change and it's pure incremental development, then a change in existing test is just a red flag. So you can find that with source control. But preferably, you want to know it before that. Okay, how do we get some high quality tests? Well, when you talk about quality, you talk about the value of a test, and that very much depends on the specificity of the requirement. So don't say something vague like the employees are listed in a table. Make it explicit, everything explicit. Say that each column has a filter. Say that each column can be sorted. Because if you make the acceptance criteria this specific, you also get specific tests. You can then expect to get a test per column that checks whether sorting works. Same for filtering for that column. Okay, so specific. Here too, you have to lead by example. So not only give examples of how to use grids and forms, but also give examples of tests. And here's again an example of the bot responding to that. Then invest in optimal test generation instructions. I covered that in this previous video, but the gist of it is that you just go into a dialogue and pointing out that certain things are missing and then asking the bot to create a better prompt, then use that prompt. And there is actually a way or a name for this called meta prompting. Well, never heard of it before, but this is what Google AI gave about it. I would call it prompt refinement, but what I want to point out here is that it is an iterative process. So um, uh, don't expect that if you do this once that you get the ideal prompt. It's going to take a little bit longer, a few more iterations. Now about test coverage. Martin Fowler, already more than 30 years ago, talked about it, and he pointed out, among other things, that it is not to assess the quality of the test. No, it's about finding untested code. Um, so what you need to do is, once you have identified this untested code, you have to find an acceptance criterion that is missing. Because apparently there was code that was there for some reason, and there must be an acceptance criterion, and or the, the the untested code is there for no reason whatsoever, and then it should be just deleted. But more likely it is that an acceptance criterion was missing, and then you figure out whether that acceptance criteria is truly missing. You have to ask your product manager, and then you ask the bot to generate an acceptance criterion test for it. And once that is done, you calculate the code coverage again, and you see whether it has improved. The way I get pretty good test coverage is to ask the bot to generate different sections and then create or identify sections and then create tests for each section that is on the page that is actually there. And that can be conditional, of course, depending on the role. Another category that I identify is input states. So what you can think of a button, for instance, that is disabled in the beginning, and you want to check that. A more interesting one is validation on forms. We have all done that. And of course, you want to have tests that put invalid data in the input fields and then check that the proper error messages show up. State transitions. We have tons of state transitions in our applications, and we want to all identify them and then um, create tests for those, navigation menus, and acceptance criteria. This is the markdown file that I use for test requirements. And you see here that I still have this in all in one file. Maybe I need to split it up. Here is the sections, the input state, input validation, state transitions. Let's zoom into that. So the first phase in finding these state transitions tests is a discovery phase. And this is quite elaborate, and it is because it was generated by Claude itself in the process that I referred to before. And so you can see here that it tries to find all elements on the page that could possibly be involved in a state transition. So it does that. Then it generates an intermediate table so that it doesn't need to go back to the code all the time. It creates an abstraction, a summary of the inventory that it has made. And then it goes actually design the test, and there too it creates a new table where all these tests are listed, and with the given when then approach and the validation steps, it has much more there. It has an example of uh, such table, and then anti-patterns, and this is also all machine generated. And then it starts planning it, and the planning involves for each test 7 steps. So read that table that I just referred to, and then of course you generate a test, and then you run them, you report it, and it failed, and then confirm completion. So it's quite elaborate. And then execute the plan. And here, this is the last, the most recent thing that I added, also generated by a bot. It's important that you indicate that you should not remove tests if you cannot implement them. Um, yeah, I saw it doing that, and so that's wrong, definitely wrong. So here, this instructed to not remove them and just indicate I couldn't do it. And we saw one example of that in a previous video. Okay. Um, Another thing that I would like to show is with the acceptance criteria test. That is at the end, and it is smart enough to conclude something here. So it reads all these files, and then it says, I need to create acceptance criteria test. These tests verify that the acceptance criteria from the user stories are actually met. Nice feedback. You know what you're talking about, or at least seem to be. Many of these are likely already covered by existing tests, sections, input state, state transitions, etc. But I should create explicit acceptance tests that directly map to each acceptance criterion. This is just mind-blowingly good. Uh, so I wanted to share that. Here's my take on why do these LLMs actually perform so well at spec-driven development. Well, it's all a matter of knowing their strengths and weaknesses, leverage their strength, and mitigate their weaknesses. So we already know that LLMs are very good at following patterns. So what we do is establish those patterns. LLMs have a limited context window attention span. That's a weakness. Well, what we do is provide step-by-step guidance and progressive disclosure. Progressive disclosure is showing first a 10,000 feet level with abstractions and little detail. And when needed, we refer to other more detailed instructions that then can also refer to more detailed instructions. And so the bot is free to, in any context, to ignore information that it doesn't need, and therefore it doesn't get this prompt window overflow. LLMs are poor at understanding our world. Oh, yes. But why does it not hurt us here? Well, when we create data models and stores, we actually create abstractions of the world, and it can understand those abstractions. LLMs can have hallucinations. Yes, we have all seen those. Well, we let them create tests that detect those hallucinations and those hallucinations that don't meet the spec. So our tests are guardrails and our protection against hallucinations. We don't know how they work internally. Well, that's not really important, but we write acceptance criteria that make them meet our goals, and that is important. So you can see here that some of the things we do to make get the most out of LLMs is can be directly mapped onto prompting, one-shot prompting and chain of thought prompting. And here we saw that applied to software development. One last bit about mindset. We have to just assume that the bot is always right. I give you an example that shows why. I had incomplete coverage. And then I looked at what wasn't covered, and it was an optional autocomplete on a page. It was the input field was optional, but I had forgotten to say that if it is used, that the value entered should be valid. And so I added the acceptance criteria and let Claude update the test set, and the coverage increased. So the bot was right. I didn't add an acceptance criterion that should have been there. So I was wrong. So you can summarize this as it is displayed here. The first work is always on ourselves.